On question number 5, we want to find the exact length of G to H. So we know we have a diameter, and we know it's perpendicular to the chord. And so what happens, I'm going to draw in a radius, like Z to G, and I know that's going to be 7. We also know that Z to F is 7. So in other words, let me get back here to my pen. We know J to Z is 5. So I want to find G to J. I'll call that like X. I can use Pythagorean theorem because I have a right angle. My hypotenuse is 7. So 7 squared equals 5 squared plus X squared. Remember, we want the exact answer in this one, so no decimals. So 49 equals 25 plus X squared. You can minus 25 from both sides. 9 minus 5 is 4, so we get 24 equals X squared. Take the square root of both sides. We want to simplify that. That's the square root of 4 times the square root of 6. So it's 2 square roots of 6. Now G to H is going to be twice that. So I take 2 times 2 square roots of 6. And our answer is 4 square roots of 6. On question number 6, we've got let's draw a picture. We got 2 parallel chords in a circle, and they are each length 16 and 30, so I know the one that's 30 is going to be closer than the one that's 16, to the closer to the center, I should say. Okay, so I'm going to, here is my 16, here's my center, and here's my 30. Okay, they're supposed to be parallel. If I didn't draw them parallel, sorry about that. And I know they're 23 centimeters apart. So what I'm going to do is I'm going to call this length X and this length 23 minus X. And then since I'm going to make it perpendicular, well, I should know it's perpendicular because I'm measuring distance. And so what happens is I'm going to draw in my radii. And that's the key on this one because I know my radiuses are the same. So my short one is 16, so I know when it's perpendicular, that's the perpendicular bisector, so that makes that 8. That makes this one 15. So what I have here is I have 2 triangles. I can say r squared equals x squared plus 15 squared. My other one is going to be r squared equals 23 minus x, if I could, plus 8 squared. Well, since I know my 2 r squareds are the same, I can set these two equal to each other. So I'm going to say, whoops, did it again. I'm going to say x squared plus 15 squared equals 23 minus x squared plus 8 squared. Well, we can simplify that, so I get x squared plus 225 equals. Now remember, 23 minus x squared is not, don't distribute your exponent, but we can take 23 minus x times 23 minus x. So 23 squared is 529. Minus 46x plus x squared plus 64. I can simplify that a tad. X squared plus 225. And let's write this in standard form. So I'm going to go x squared minus 46x, and then 529 plus 64 gives us 593. Notice when I subtract x squared from both sides, they cancel. So I think I just want to get x by itself. So let's subtract 593 from both sides. So if we take 225 minus 593, we get negative 368 equals negative 46x. Well, we'll divide both sides by negative 46. So if I take negative 368 divided by negative 46, x turns out to be 8. So I'll write that in here. So this is 8, and that would be 15. Oh, and notice we got similar triangles, don't we? Actually, congruent triangles. And then I want to find the length of the radius. So I just need to go back here and find r. I think I'll use my first one. So I'm going to say r squared equals x, which is 8 squared, plus 15 squared. So r squared is 64 plus 225. If I take 64 plus 225, I get 289. Take the square root of that. My radius is 17. That's definitely a complicated question, but kind of a fun one, I think. Okay, I want to find x. I know the central angle is the same as the arc. So in other words, my arc is 94. So x is going to be 94 divided by 2, which is 47 degrees.